Hello everyone and welcome to this video on Lean Six Sigma full course by Simplilearn. It's easy to get stuck in rut sometimes, but there's always room for improvement. The world of business is constantly changing, and staying on the top of the latest trends and technologies is essential for success. One of the most valuable skills you can have is the ability to continuously improve your process and systems. That's where Lean Six Sigma comes in. Lean Six Sigma is a management system that focuses on reducing waste and increasing efficiency. By applying these principles, you can eliminate unnecessary steps, cut down on resources and costs, and improve quality. This leads to faster product delivery, better customer satisfaction, and higher profits. Don't let yourselves fall behind. Take this opportunity to learn what Lean Six Sigma is all about and how you can apply it in your business. You will learn about the importance of process, flow mapping, 5S Kaizen, and other fundamental principles that can help you streamline your operations. The video covers a wide range of topics including statistics, data analysis, and project management. With this knowledge, you will be able to identify and eliminate waste in your own process, improve your products or service, and create more value for your customers. It's essential for any successful businessman or woman to continually learn and improve their skills. So what are you waiting for? Let's get started.
Six Sigma is a set of tools and techniques that have helped several companies around the world achieve business success. Hi guys, I'm Rahul from Simplilearn, and let's get started with our introduction to Six Sigma. Now let's understand this better with an example. Here let's talk about how things were before Six Sigma was introduced. Here Jenny and James are having a conversation with each other. Jenny is James's manager and she's not happy at all. She says James is in a lot of trouble. This is because she found out that the customers weren't happy with the organization's service and the operational costs were way too high. And as manager, James had to make sure that this did not happen. Now let's have a look at the same scenario in present day. Here we have Jenny congratulating James. She's very impressed with his work, but James says it's all thanks to Six Sigma methodology. So Jenny asks, she wants to know more about Six Sigma. So to understand Six Sigma, here's what you need to know. Firstly, we'll have to understand what is Six Sigma, what its advantages are, some of its methodologies, what are the different roles in a Six Sigma team, what is lean, what is a lean process, and what is Lean Six Sigma. So now let's get started with understanding what exactly is Six Sigma. The Six Sigma methodology makes sure to find as well as eliminate any sort of defect or variation that could be affecting your product, service, or process. Now this methodology is statistics based, is data driven, and focused on continuous improvement. Now this means that there's no end goal in the horizon. There's always another goal to reach. There are three core ideologies behind Six Sigma. The first one states that for any business to be successful, there's continuous efforts that are required so that you can achieve stable as well as predictable process results. The second ideology states that in any business or manufacturing process, there are certain characteristics that can be defined, measured, analyzed, and controlled. The final ideology says that along with the rest of the organization, the top level management plays a very important role to making sure that there's sustained quality. Now let's talk about the advantages of Six Sigma. Six Sigma can help produce a roadmap or a path through which you can easily find and reduce any sort of organizational risk and reduce the operational costs. Another advantage is that it helps improve the efficiency of the process and making sure that it works in a timely manner. It decreases defects, improves the overall tracking and monitoring process, and ensures that the products are aligned with the company's policies. It is also reported that it greatly helps improve customer as well as vendor satisfaction. It helps improve the cash flow and ensures that the products are complying with the regulations of the organization. Now let me tell you about the process of Six Sigma. Now Six Sigma projects are of basically two methodologies, the DMAIC and the DMADV. Now let's talk about DMAIC in detail. That's short for define, measure, analyze, improve, and control. This is one of the most commonly used methodologies in the world. This is commonly used by companies when they have to fix or improve an already existing product or process that does not meet the company's standards. Now let's have a look at the process. First phase is the define phase. In this phase, you define the problem that the customers are facing, you find out where you can improve, and you clearly understand what the customers require of you. The second phase is the measure phase. Now in this phase, you actually identify how well the process is doing in its current unaltered state. In the analyze phase, you process the data that you get from the measure phase and determine what exactly is the cause of the delay or variation. In the improve phase, you start by making small changes to the business process and make sure that the problem you identified earlier is being taken care of. And finally, in the control phase, you control the new process so that it doesn't go wrong and use the same knowledge for future processes. Now let's have a look at DMADV. This is short for define, measure, analyze, design, and verify. Now this is also commonly known as DFSS or the design for Six Sigma. Now this is commonly used by companies around the world when they have a new product that needs to be created all the way from scratch. In the first phase, which is the define phase, you define what the goal of the project is and what the customers require of you. In the measure phase, you measure as well as determine what the customer needs and how they respond to your products. In the analyze phase, you perform analyses to determine how you can improve your product or service so they can better serve your customers. In the design phase, you set up process details and make optimizations to the design to make sure your customer is satisfied. And finally, in the verify phase, you check how well the design is working out and how well it meets the customer's needs. Now before we go on, let's talk about how Six Sigma was used in reference to the earlier example, the situation that James was facing. A survey conducted by the organization James was working for indicated that the customers weren't very happy with the organization. So they decided to fix that with the help of Six Sigma. So they decided that the DMAIC methodology would be best suited to solve their problem. So let's have a look at what they did. Firstly, in the define phase, they used a tool called the voice of the customer. This tool represented the needs as well as requirements of the customer. This showed that the customers expected prompt delivery, the correct product selection, and a knowledgeable distribution team from the company. And now onto the measure phase. The company wanted to know why the customers didn't like them, so they performed some data collection. From there, they found out that they took 56% longer than other companies to deliver their product. So they decided to reduce the amount of time it takes between order entry and the delivery of the product. And now in the analyze phase. Here they knew what the issue was, but they wanted to know what exactly made their product's delivery so slow. Why were the customers receiving the product so late? Then they performed some analysis. Their analysis showed the possible causes. It could have been inaccurate sales plans, issues with their safety stock, issues with their vendors' delivery performance, and falling behind on the manufacturing schedule. Further analysis also indicated that most of their sales, almost 80%, came from 30% of their products. The issue was that they didn't have enough safety stock to satisfy the customers who required that 30% of products. And now onto the improve phase. So now that they knew what was causing their problem, they wanted to solve it. They began to have monthly reviews and tried to make sure that their in-demand products stayed in demand. Another thing that they wanted to focus on was to make sure that they could order and provide the customer with the products that they wanted. And finally, onto the control phase. They began to set up plans so that they could monitor the sales of that 30% of products that were selling the most. Each year, they would review how well a product was selling and replace it if it had fallen out of favor. Now, let me tell you what a Six Sigma team consists of. Let's talk about the roles in a Six Sigma team. First up is level 7. Now, these are individuals who are at the novice level. Now, these individuals don't know in great detail about what the project is, but they have a basic understanding of the principles and the methodology behind the program. Now, they usually support with smaller projects and with smaller issues, but these individuals found the foundation for the people who decide where the program is going. And now we're at level 6. Now, these are individuals who have a yellow belt certification. Now, they are core members of the Six Sigma team who have an understanding of how the basic metrics work and how they can perform some sort of improvement. Now, they have their own areas of expertise and they're required to determine certain processes that need to improve. At the same time, they're also in charge of smaller improvement projects. Now, level 5. These are people who have a green belt certification. Now, these individuals are usually part-time professionals who have a number of different duties to fulfill. They focus on smaller Six Sigma projects. They're usually involved with gathering data, performing some sort of experiment, and analyzing information. They also assist with black belt projects. And now we're at level 4. These are individuals who have a black belt certification. They're usually team leaders of a Six Sigma project. They complete 4 to 6 projects a year and are experts in the principles, methodologies, and lean concepts. Thanks to their understanding of statistical experimental design, they can also understand the hidden reasons behind why a particular product failed. And now we're at level 3. These are individuals who have a master black belt certification. Now these are individuals who are experts when it comes to resources, the practices, and the methodologies that are employed in Six Sigma. Their main emphasis is to coach, train, and certify black belts. They also are involved with other Six Sigma leaders to ensure a company's goals are met. Now level 2. These individuals are called champions. So they work really closely with the executives and usually have a role like a senior or a middle executive level role. They also have a clear understanding of what exactly is the company's vision and mission. They also understand metrics so that they can set up a Six Sigma project that lines up with the company's goals. They're responsible for removing any sort of roadblock that could hamper the success of a project. And finally, we're at level 1. These are the executives. Now these individuals represent the highest level when it comes to a Six Sigma team. Now they have training as well as experience through which they can set up Six Sigma projects that clearly line up with the company's goals. Their main emphasis is to ensure that the project is able to add value to the organization and at the end of the day is successful. Now this is when Jenny interjects. She wants to know about Lean. John tells her that Lean, just like Six Sigma, is another methodology. So what exactly is Lean? Now Lean is a methodology that has a very important ideology to make sure that there's continuous optimization of the processes and there's an elimination of waste. So what's waste? So waste is basically any part of the process that the customer doesn't want to pay for. It is a process that does not add any value to the customer. Now coming back to Lean, here are some of its characteristics. Whenever decisions are being made in a Lean team, the main emphasis is to understand how it exactly adds value to the customer. Every member in a Lean team has a clear understanding of what exactly are the goals of the organization. It also encourages employees to push for further success even if the organization is in a good place or is already doing well. There's also an emphasis on cross-functional collaboration and communication. Lean focuses on answering the difficult question or the complex ones rather than employing short-term fixes. And with Lean, you can easily prepare for issues that can come up in the future or improvise in unexpected circumstances. So let's talk about how Lean and Six Sigma are different from one another. The Lean methodology aims to reduce waste. It does so by analyzing the workflow. It also emphasizes on minimizing resource usage and improving customer value. Now let's talk about Six Sigma. The aim of Six Sigma is to provide near perfect results. It wants to reduce costs and improve customer satisfaction. Basically, both of them are moving towards the same goal, to reduce the amount of waste and to create efficient processes. Now let's talk about the process of Lean. Now there are 5 different steps. Let's start with the first one, identifying value. You need to identify value by determining what exactly is the problem you're trying to solve for the customer. The second step is to map your value stream. You need to map the workflow of your company. You need to focus on the different actions and the people that are involved with the process. You need to be able to identify which parts of the process are able to add value and the ones that don't. The third step is to create a flow. You need to break up your work into smaller silos and visualize the workflow so that you can easily identify problems that might show up later. The next step is to establish pull. You need to set up a system through which products are created only when there is a demand or a requirement for it. Through this, you can optimize resource capacity. And finally, we're at the 5th step, which is continuous improvement. You need to ensure all your employees at all levels are involved in the continuous improvement of the process. So what exactly is Lean Six Sigma? What if you could combine the best of both worlds? The combination of Six Sigma and Lean methodology led to the creation of Lean Six Sigma. Lean Six Sigma is a methodology that aims to solve problems, removes any form of waste or inefficiency, and improving the working conditions of employees to make sure that they can serve the customers better. Now, this is a combination of the tools, methods, and principles that are employed in Lean and Six Sigma. Let's talk about some of its advantages. It aims to provide customers with a better experience by streamlining the process. With efficient power flows, it aims to drive higher results. It can reduce cost, remove waste, and prevent defects. It can help the organization handle day-to-day problems. The decreased lead times help increase capacity and profitability. And finally, it helps with people development and improving the morale of the organization.
The organizational benefits of Six Sigma are as follows. A Six Sigma process eliminates the root cause of problems and defects in a process. Sometimes, the solution is creating robust products and services that mitigate the impact of a variable input or output on a customer's experience. For example, many electrical utility systems have voltage variability up to and sometimes exceeding a 10% deviation from nominal value. Thus, most electrical products are built to tolerate the variability, drawing more amperage without damage to any components or the unit itself. Using Six Sigma reduces variation in a process, and thereby reduces waste in a process. It ensures customer satisfaction and provides process standardization. Rework is substantially reduced because one gets it right the very first time. Further, Six Sigma addresses the key business requirement. Six Sigma can also be used by organizations to gain advantage and become world leaders in their respective fields. Ultimately, the whole Six Sigma process is to satisfy customers and achieve organizational goals. Let us understand how Six Sigma works in this screen. Six Sigma is successful because of the following reasons. Six Sigma is a management strategy. It creates an environment where the management supports Six Sigma as a business strategy and not as a standalone approach or a program to satisfy some public relations need. Six Sigma mainly emphasizes the DMAIC method of problem solving. Focus teams are assigned well-defined projects that directly influence the organization's bottom line with customer satisfaction and increased quality being byproducts. Six Sigma also requires extensive use of statistical methods.
Imagine you're the manager of a supermarket chain. You've noticed that two things need your immediate attention. The first issue is how to handle the different kinds of waste that you encounter at your supermarket. The next one requires you to address the supply chain issues at the supermarket, which are causing delays to the morning delivery of milk, leading to customer dissatisfaction and attrition. These problems can be solved by incorporating two of the most popular quality management methodologies in the world, Lean and Six Sigma. One famous for its ability to handle waste, and another known for process improvement. But what if there was a methodology that combined the concepts of both Six Sigma and Lean? One that could solve all your issues? Well, there is. Lean Six Sigma. Before we dive into Lean Six Sigma, let's take a closer look at its parent methodologies. First off, Lean is a methodology that focuses on providing value to the customer, eliminating waste, continuous improvement, reducing cycle time. Lean and Six Sigma both aim to handle waste. But what is this waste? Waste is any step or action in the process that a user does not gain any value from. In short, things that users wouldn't want to pay for. Why would a consumer want to pay extra for the additional truck that was required to deliver milk to the supermarket just because the other one broke down? This waste can be divided into 8 categories. Let's have a look at each of them. 1. Transportation. This waste refers to the excess movement of people, tools, inventory, equipment, and other components of a process than it is required. 2. Inventory. This waste occurs due to having more products and materials than required. This can cause damage and defects to products or materials, greater time for completion, inefficient allocation of capital, and so on. 3. Motion. This refers to the time and effort wasted due to unnecessary movement of people, equipment, or machinery. This could be sitting through inventory, double data entry, and so on. 4. Waiting. This can be time wasted waiting on information, instructions, materials, or equipment. 5. Overproduction. This is the waste created due to producing more products than required. 6. Overprocessing. It refers to more work, more components, or more steps in a product or service than required. 7. Defects. This is the waste originating from a product or service that fails to meet customer expectations. 8. Skills. This waste refers to the waste of human potential, underutilizing capabilities, and delegating tasks to people with inadequate training. For years now, many systems have emerged that use the Lean methodology to identify and handle the different kinds of waste. Some of the more popular and effective ones are JIT, or Just in Time, 5S, and Kanban. The JIT methodology focuses on reducing the amount of time the production system takes to provide an output, and the response time from suppliers to customers. 5S is another methodology that focuses on cleanliness and organization while improving profits and efficiency. Kanban is also another popular methodology to achieve lean. It is a visual method to manage tasks and workflows. Kanban enables users visualize the workflow to identify issues in the process and fix them. These methodologies help in optimizing the waste production and are often used together to maximize results. So that's the first problem solved. Now, let's have a look at how you can improve the supermarket supply chain efficiency. For that, let's have a look at the other part of Lean Six Sigma, Six Sigma. Six Sigma is a set of tools and techniques that are used for process improvement and removing defects. Let's see how Six Sigma makes that possible. Six Sigma has two major methodologies, DMAIC and DMADV. You can learn more about these two methodologies by checking out our Six Sigma in 9 minutes video by clicking on the top right corner. Let's have a closer look at DMAIC, since Lean Six Sigma uses the DMAIC methodology of Six Sigma. DMAIC is an acronym for Define, Measure, Analyze, Improve, Control. It is used to improve existing products and processes so that it can meet the customer's requirements. In the Define phase, you determine what the goals of the project are. In this case, you want to reduce the amount of time taken to deliver milk from the warehouse to the supermarket, so that it is stocked on the supermarket shelves before 8:30 in the morning. In the Measure phase, you measure the performance of the current unaltered process. The milk truck leaves at 7:30 a.m. in the morning and can take one of three routes, A, B, and C. Route A is currently the preferred one, as it takes only 60 minutes to reach the supermarket, compared to the routes B and C, which take 70 and 80 minutes respectively. In the Analyze phase, you find out why the defects exist. Since routes B and C were school bus routes, by reducing the starting time by 1 hour at 6:30 instead of 7:30 meant avoiding the traffic. Routes B and C now take 40 to 45 minutes to reach the supermarket. Route A still takes the milk truck 1 hour to get to the supermarket, even when the truck leaves at 6:30 a.m. In the Improve phase, performance can be improved by addressing and eliminating the root causes. Now that you've realized that advancing the milk pickup by an hour and changing the route to Route B can save time, you change the process accordingly, providing your workers with ample time to stock the milk into the shelves before the morning rush. And finally, in the Control phase, you make regular adjustments to control new processes and future performance. You continue to monitor the delivery times and try out alternate routes to continually improve the process and ensure even faster delivery. This process change led to reduced man-hours and cost, enhanced sales, and customer retention. The Lean Six Sigma methodology offers many such benefits to businesses. Let's take a look at some of them. 1. Increase in profits. 2. Standardized and simplified process. 3. Reduced errors. 4. Employee development. 5. Value to customers. And that is Lean Six Sigma for you.
The term lean refers to creating more value to customers with fewer resources. It means reducing unwanted activities or processes that do not add value to the product or service for the customer. The lean philosophy is to provide perfect value to the customer through a perfect value creation process that has zero waste. While the ultimate goal is to achieve zero waste, you may not always get that in the first couple of tries. However, you will achieve minimum waste and continue to move towards zero waste eventually. Hence, lean is the path towards perfection. Lean is about optimizing the process from beginning to end, eliminating non-value adding activities, NVAs, and increasing flow to ensure that parts and services are provided to customers more quickly. If quality is the word to describe Six Sigma, then speed is the word to describe lean. Let's understand the importance of lean. There are many benefits of lean, and some of them are reduce cost, reduce cycle time, more throughput, and increase productivity. Despite all of these benefits, Lean is not implemented by most of the organizations because of the misconception that it is only suited in manufacturing areas. The reason for this misconception is the beginning of Lean. It began and grew in popularity in the manufacturing areas, starting with Toyota. In recent years, one can notice more applications of Lean in other areas, such as healthcare and the transactional space. However, the truth is that Lean concepts can be applied in any business and in any process. On the next screen, let's discuss how Lean and Six Sigma combine. Lean and Six Sigma are two different principles or methodologies that combine to form and create one powerful continuous improvement methodology. They have various overlapping goals toward the improvement, with the aim of creating the most efficient system. Though the approaches are different, the methods complement each other. Lean Six Sigma takes the power and rigor of Six Sigma methodology and combines it with Lean concepts, leading to faster results, better quality, and improved customer satisfaction. Let's look at the differences between Lean and Six Sigma. Lean focuses on efficiency by identifying value from the customer's point of view, removing unnecessary steps in the process, and improving process speed or velocity. On the other hand, Six Sigma focuses on effectiveness with the help of breakthrough processes, identifying root causes, and reduction in variation. Therefore, when Six Sigma is combined with Lean, it is possible to achieve business transformation. So remember, Lean is about speed with a focus on efficiency, Six Sigma is about quality with a focus on effectiveness, and Lean Six Sigma brings the best of both together. To yield a better result, first implement Lean to streamline the process. This helps to understand the chronic problems and the ways to handle them quickly. Once the problem is identified, use Six Sigma methodology to analyze the issues and provide business improvement transformation. In other words, Lean is used to reduce the waste, and Six Sigma is used to reduce the variation.
Let us understand process mapping in this screen. Process mapping refers to a workflow diagram which gives a clear understanding of the process or a series of parallel processes. It is also known as process charting or flow charting. Process mapping can be done either in the measure phase or the analyze phase. The features of process mapping are as follows. Process mapping is usually the first step in process improvement. Process mapping gives a wider perspective of the problems and opportunities for process improvement. It is a systematic way of recording all the activities performed. Process mapping can be done by using any of the methods like flowcharts, written procedures, and detailed work instructions. Let us understand process input and output variables in this screen. Any improvement of a process has a few prerequisites. To improve a process, the key process output variables, KPOV, and key process input variables, KPIV, should first be measured. Metrics for key process variables include percent defective, operation cost, elapsed time, backlog quantity, and documentation errors. Critical variables are best identified by the process owners. Process owners know and understand each step of a process and are in a better position to identify the critical variables initially. Once identified, the relationship between the variables is depicted using tools such as SIPOC and cause and effect matrix. The process input variables results are compared to determine which input variables have the greatest effect on the output variables. This lesson will focus on the improve phase of the DMAIC process. The improve phase comes after the analyze phase. In the analyze phase, the data was analyzed and some patterns were found to identify where the problem lies. In this lesson, we will review the improve phase to understand how to go about the improvements, their validation, etc. Let us start with the objectives of this lesson in the next screen. After completing this lesson, you will be able to describe the concepts of design of experiments, DOE, explain the uses of residuals analysis and Box and Cox transformation technique, discuss the cause and effect matrix and the 5 Why tool in root cause analysis, explain the Lean and Kaizen techniques. Let us proceed to the first topic of this lesson in the following screen. In this topic, we will discuss design of experiments in detail. Let us learn about design of experiments in the following screen. Design of experiments, or DOE, consists of a series of planned and scientific experiments that test various input variables and their eventual impact on the output variable. Design of experiments can be used as a one-stop alternative for analyzing all influencing factors to arrive at a successful model. DOE is applicable where multiple input variables, known as factors, affect a single response variable. An output variable is the variable which may get affected due to multiple input variables. DOE is preferred over one factor at a time, or OFAT experiments, because it does not miss interactions. With techniques like blocking, experimental error can be eliminated. The trials should be randomized to avoid concluding that a factor is significant when the time at which it is measured or the sequence followed may have influenced the response's result. An example of blocking is highlighted in the table given on the screen. With techniques like replication, many experiments can be conducted to ensure a robust model. We will understand the concept of design experiments through an example in the upcoming screen. To understand DOE and the main effects, consider the following example. Suppose the objective of the experiment is to achieve uniform part dimensions at a particular target value to reduce variations. The inputs, X, or factors that affect the output are cycle time, mold temperature, holding pressure, holding time, and material type. The process is the molding process, and the output or the response of the experiment is the part hardness. The components of the DOE in this example will be described in the next screen. Output response, factors, levels, and interactions are the components of the DOE in the given example. Click each component to learn more. The response variable is the part hardness and is measured as a result of the experiment and is used to judge the effects of factors. Factors of this experimental setup are cycle time, mold temperature, holding pressure, holding time, and material type. Factors can be varied and are called levels. The molding temperature can be set at 600 degrees Fahrenheit or 700 degrees Fahrenheit. Plastic type can be fillers and no fillers, and the material type has 2 levels of nylon or acetal. Interactions refer to the degree to which factors depend on one another. Some experiments evaluate the effect of interactions. In the molding example, the interaction between cycle time and molding temperature is critical. The best level for time depends on what temperature is set. If the temperature level is higher, the cycle time may have to be decreased to achieve the same response from the experiment. Let us understand full factorial experiments through an example. Full factorial experimental design contains all combinations of all levels of all factors. This experimental design ensures no possible treatment combinations get omitted. Hence, full factorial designs are often preferred over other designs. The table shown here is for a 2-way heat treatment experiment. There are 2 factors, oven time, X2, and the temperature, X1, at which the material is drawn out of the oven. The output, Y, of the experiment is the hardness of the material. Each of the factors has 2 levels. This example illustrates the concepts of main factor and interaction effects. From the table, it is clear that without repetition, the experiment will have 4 different outcomes based on the changes in levels of factors. Each experimental trial here is repeated to give a total of 8 values. Let us now analyze the mean effect. An analysis of the means helps in understanding how a change in temperature at which the material is drawn creates a difference in the average part hardness. This affects the output and is called the main effect. Analysis of means also tells how a change in oven time creates a difference in the average part hardness. This is also the main effect. Analysis of means explains how interaction between temperature and time affects the average part hardness. This is known as the interaction effect. Let us next understand the concept of main effect. For calculating the main effect, the means have to be calculated. Hence, to calculate the main effect of draw temperature, the mean of the hardness values has to be calculated. The values are populated in the corresponding columns of draw temperatures. The columns have been labeled A1 and A2. The value of the mean of A1 is 91, and of A2 is 82. Plotting the data on a graph shows that changing draw temperatures changes the average hardness. Similarly, we calculate the mean of hardness values in B1 and B2. The values are 87 and 86, which are plotted on a graph. It can be seen that changing the oven time does not affect the average hardness. Now let us understand how the interaction between temperature and time affects the average part hardness. To check how draw temperature and oven time interact, the mean values are calculated by taking the repetition response. Hence, the cell A1B1 has the mean of the values 90 and 87. The cell A2B1 has the mean of the values 84 and 87. After the mean values are calculated, they are plotted on a graph. The graph shows that to reduce interactions, low temperature and high oven time should be selected to have the desired output of high hardness, also called Brunel hardness. If low hardness is the desired output, the experimental setup should have high draw temperature and high oven time. The ideal case is represented by the parallel lines, which give the desired output based on the main effect without being affected by the interaction between the factors. The parallel lines are shown as a dotted line. The mean of the factors are also calculated and shown in the small table. In this, we will introduce the concept of runs in design of experiments. The numbers of experiments in a DOE setting is known as runs. A full factorial experiment without replication on 5 factors and 2 levels is 2 raised to the power of 5, which equals 32 runs. A full factorial experiment with 1 replication on 5 factors and 2 levels is 32 plus 32, which equals 64 runs. A half fractional factorial experiment without replication on 5 factors and 2 levels is 2 raised to the power of 5 minus 1, which equals 16 runs. A half factorial experiment with 1 replication on 5 factors and 2 levels is 16 plus 16, which equals 32 runs. The number of combinations can be determined using the formula L to the power of F, where L is the number of levels and F is the number of factors. Half fractional factorial is calculated using the formula L to the power F minus 1. At 3 levels, 5 factors full factorial experiment would amount to 243 trials, and half factorial experiments would require 81 trials. The difference between full factorial and half fractional factorial experiments can be seen from the number of runs. Let us proceed to the next topic of this lesson in the following screen. In this topic, we will discuss root cause analysis in detail. We will learn about residuals analysis in the following screen. While performing the regression analysis of a linear or nonlinear model, you will get a model with the predicted values. Some of the data might fit within that model, whereas others may be scattered across. The model equation predicts one value for y at level x. However, the actual value for y observed at that level of x is different from the predicted value. This difference between the observed value of the dependent variable y and the predicted value is called residual. The formula to calculate residual is observed value minus predicted value. Residuals are considered to be errors, and each data point has one residual. You can validate the assumptions on random errors as they are independent, exhibit normal distribution, have a constant variance sigma square for all the settings of the independent variables, and finally, have a mean as 0. In the next slide, we will continue to discuss residuals analysis. As discussed in the previous screen, while performing any regression analysis, you will observe that not all the data fits into the linear model, as the linear regression model is not always appropriate for the data. Therefore, you should assess the appropriateness of the model by defining residuals and examining the residual plots. If all assumptions are satisfied, the residuals should randomly vary around 0, and the spread of the residuals should be the same throughout the plot. That is, no systematic patterns are observed. Remember, in residuals analysis, both the sum and the mean of the residuals are 0. Residuals and diagnostic statistics allow you to identify patterns that either poorly fit in the model with a strong influence on the estimated parameters, or have a high leverage. It is helpful to interpret these diagnostics together to understand any potential problems with the model. In the next screen, we will learn about data transformation using the Box-Cox method. The available data must be transformed when it does not exhibit the normal distribution. Box and Cox, in the year 1964, developed a procedure for estimating the best transformation to normality within the family of power transformation. It works by taking the current Y data and raising it to the power known as lambda. The formula for transformation of Y is represented as Y asterisk equals Y to the power lambda minus 1, the whole divided by lambda. This formula is used where the value of lambda is not 0. If the value of lambda is 0, you can use natural logarithm to transform Y. The family of power transformations can be used for the following. For converting a data set so that parametric statistics can be used. Here, lambda is a parameter to be defined from the data. For any continuous data greater than 0, this will not work when the values are less than or equal to 0, transforming specs. Note that the use of the transformation does not guarantee normality. In the next screen, we will continue the discussion on data transformation using Box and Cox. The table on the screen shows how the data can be transformed using lambda. The first column lists down values of lambda, and the second column shows the transformed value. If the value of lambda is -2, it becomes y to the power -2 after the transformation, which is 1 divided by y squared. Similarly, if the value of lambda is -1 after transformation, it becomes y to the power of -1, which is 1 divided by y, and so on. Note that you will use a different formula when you have the value of lambda as 0, wherein you will take natural log of the value y. Similarly, transform values are also shown on the screen. Click the Example button to know more. Let us look at an example of how data transformation is done using Box-Cox. The difference between original data and the data transformed using Box-Cox is shown on the screen. Figure 1 shows the original data plotted on a histogram. Here, you can see that this data is abnormal. In Figure 2, the Box and Cox procedure is applied on the original data, and it is transformed. You can see that the data in the second figure is more normal than Figure 1. Let us learn about process input and output variables in the following screen. Process improvement has a few prerequisites. Before a process can be improved, it must first be measured to assess the level of improvement required. The first step is to know the input variables and output variables, and check for any relationship. The SIPOC map and the cause and effect matrix are very helpful. There are many ways to measure the key process variables. Metrics such as the percent defective, operation costs, elapsed time, backlog quantity, and documentation errors can be used. Critical variables are best identified by the process owners. Once they are identified, cause and effect tools are used to establish the relationship between variables. A cause and effect matrix is shown on the screen. The key process input variables have been listed vertically, and the key process output variables horizontally. For each of the output variables, a prioritization number is assigned. Numbers which reflect the effect of each input variable on the output variable are entered in the matrix. The process output priority is multiplied with the input variables to arrive at the results for each input variable. The values are added to determine the results for each input variable. For process input variable 1, the output variables are 3, 4, and 7, with a prioritization value of 4, 7, and 11, respectively. Therefore, multiplying the output variables with their corresponding prioritization numbers and adding those gives 117, which is around 33% of the total effect. The process input variables' results are compared to each other to determine which input variable has the greatest effect on the output variables. Click the Cause and Effect Matrix Template button to view another template. A sample of the Cause-Effect Matrix, or CE matrix, is shown here. The CE matrix gives the correlation between input and output variables. In this screen, we will discuss the steps to update the CE matrix. The steps for updating the Cause and Effect matrix are: list the input variables vertically under the column Process Inputs. List the output variables horizontally under the numbers 1 to 15. These output variables are important from the customer's perspective. One can refer to either the QFD or the CTQ tree to know the key output variables. Rank the output variables based on customer priority. These numbers can also be taken from the QFD. The input variables with the highest score become the point of focus in the project. Another method to establish the cause-effect relation is the cause and effect diagram. This is explained in detail in the following screen. The cause and effect diagram is used to find the root cause and the potential solutions to a problem. A cause and effect diagram breaks down a problem into bite-sized pieces and also displays the possible causes in a graphic manner. It is also known as the fishbone, the 4M, or the Ishikawa diagram. It is commonly used to examine effects or problems to find out the possible causes and to indicate the possible areas to collect data. The steps involved in the cause and effect diagram are: all the possible causes of the problem or effect selected for analysis are brainstormed. The major causes are classified under the headings of materials, methods, machinery, and manpower. The cause and effect diagram is drawn, with the problem at the point of the central axis line, and the causes on the diagram are written under the classifications chosen. The next screen illustrates the cause and effect diagram with the help of an example. The diagram shows the cause and effect diagram for the possible causes of solder defects on a reflow soldering line. This diagram helps in collecting data and discovering the root cause. During brainstorming, the group looked at all the major causes and then grouped them under the main headings. Under materials, causes like types of solder paste, components, and the components packaging used are considered. The major causes under methods are technology and preventive maintenance. Similarly, operator and schedule are placed under manpower, while tools and oven are grouped under machinery causes. The next screen will discuss another root cause analysis tool in detail. 5Y is one of the tools used to analyze the root cause of a problem. The responsibility of the root cause analysis lies with the 5Y analysis team. The technical experts have a great responsibility, as the conclusion will be drawn from the way the drill down of the symptoms is carried out. The 5Y is a very simple tool, as it poses the why question to every problem till the root cause is obtained. It is important to know that the 5Y tool does not restrict the interrogation to 5 questions. Why can be asked as many times as required, till the root cause for the problem is found. It can be used along with the cause and effect diagram. The following screen will explain the process of the 5 Why technique. The process for the 5 Why technique is: identify the problem and emphasize the problem statement. Arrange for a brainstorming session with the team, including subject matter experts, process owners, and team members. Explain the purpose and the problem statement. Analyze scenarios working backwards from the problem. Ask why for the answers obtained until the root cause is found. Normally, reasons like insufficient resources and time become the root causes. If the drill down in brainstorming is carried out in the right direction, it is often found that the root cause is related to the process. Therefore, the occurrence of a problem is often due to the process and not an individual or a team. In the next screen, we will understand the concept of the 5 Why technique with the help of an example. The process for the 5 Why technique is: identify the problem and emphasize the problem statement. Arrange for a brainstorming session with the team, including subject matter experts, process owners, and team members. Explain the purpose and the problem statement. Analyze scenarios working backwards from the problem. Ask why for the answers obtained until the root cause is found. Normally, reasons like insufficient resources and time become the root causes. If the drill down in brainstorming is carried out in the right direction, it is often found that the root cause is related to the process. Therefore, the occurrence of a problem is often due to the process and not an individual or a team. In the next screen, we will understand the concept of the 5 Why technique with the help of an example. In this topic, we will discuss lean tools in detail. Let us learn about lean techniques in the following screen. The 8 lean techniques are Kaizen, Bokoyoke, 5S, Just-in-Time, Kanban, Jidoka, Tact Time, and Haijunka. Click each technique to know more. Kaizen, or continuous improvement, is the building block of all lean production methods. Kaizen philosophy implies that all incremental changes routinely applied and sustained over a long period of time results in significant improvements. The second technique is Bokoyoke. It is also known as mistake-proofing. It is good to do it right the first time, and even better to make it impossible to do it wrong the first time. The prompt received to save the Word document before closing it without saving is an example of Bokoyoke. 5S is a set of 5 Japanese words, which translate to sort, set in order, shine, standardize, and sustain. This is a simple and yet powerful tool of lean. The sort principle refers to sorting items according to a rule. The rule could be frequency of use or time of use. After sorting, the objects are set in order. The place for everything is defined, and everything is placed accordingly. Cleaning of the area refers to the shine principle. The 4th step requires formation and circulation of a set of written standards. The last step refers to sustaining the process by following the standards set earlier. 5S is useful as a framework to create and maintain the workplace. Just-in-time, or JIT, is another lean technique. This technique philosophizes about producing the necessary units in the necessary quantity at the necessary time with the required quality. As an item is removed from a shelf of a supermart, the system confirms it and automatically sends a note for replenishment. This kind of technique can be used in an organization to prevent accumulation of inventory. The 5th technique is known as Kanban, which means signboard in Japanese. Kanban utilizes visual display cards to signal movement of material between the steps of a product process. This is one of the examples of visual control in lean. The next technique is Jidoka. It means automation with human touch and is sometimes known as automation. Jiduka implements supervisory function in the production line and stops the process as soon as a defect is encountered. The process does not start again till the root cause of the defect is eliminated. Takt time is the maximum time in which the customer demands need to be met. For example, a customer needs 100 products, and the company has 420 minutes of available production time. Takt time equals time available divided by demand. In this case, the company has a maximum of 4.2 minutes per product. This will be the target for the production line. The final technique is Hygienka, which means production leveling and smoothing. It is a technique to reduce waste occurring due to fluctuating customer demand. Let us understand the concept of cycle time reduction in this screen. Cycle time reduction refers to the reduction in the time taken for a complete process. Implementing lean techniques reduces cycle time and releases resources faster than any other method. Low cycle time increases productivity and throughput. Lean techniques release resources early, achieving more production with the same machinery. Internal and external waste is reduced, and the operational process is simplified with a decrease in product damage. All these factors help in satisfying the customer and staying ahead in competition. The following screen describes the concept of cycle time reduction through an example. The changes brought by implementing lean techniques on an existing process are illustrated in the given diagram. Things to be noticed are number of operators used, work allocation to the operators, path or the movement in the process, and flow of the process. Notice the changes brought about by implementing lean techniques on the old process. First, the path followed by the material in between the process is considerably reduced. This decreases the cycle time for the entire process. Second, the number of operators is reduced to 3 when compared to 5 in the old process. Operator 1 can now work on Process 1 and Process 4. Similarly, Operator 2 can work on Process 2 and Process 3. Hence, there is an increased productivity of the operators, and the remaining skilled operators can be used in some other process or system. The next screen will introduce the concept of Kaizen and Kaizen Blitz. Kaizen means good change in Japanese. Kaizen is a continuous improvement method to improve the functions of an organization. The improvements could be in process, productivity, quality, technology, and safety. It brings in small incremental changes to the process. Kaizen Blitz is known as Kaizen Event or Kaizen Workshop. If the event is tightly defined and the scope is evident for implementation, processes can be easily changed and improved. Teams could improve processes through creative problem-solving methods in structured workshops over a short timescale. The next screen will provide the differences between Kaizen and Kaizen Blitz. The differences between Kaizen and Kaizen Blitz are: Kaizen is a method that brings continuous improvement in the organization, while Kaizen Blitz is a workshop or an event that brings in change. Kaizen brings in small incremental changes in the organization. There are no major changes made within the processes. Kaizen Blitz is applied when a rapid solution is required. The Kaizen method follows a step-by-step process. It standardizes, measures, and compares the process with the requirement before improving it. Kaizen Blitz plans for the event, executes it, arrives at a solution, and follows it through. All the people of the organization are involved in Kaizen, whereas Kaizen Blitz is led by the top management and others are invited to participate. The decision-making lies with the upper management. In Kaizen, the process is standardized, and measurements are regularly collected and compared before the decision is taken. This relatively delays the process of decision-making. In Kaizen Blitz, decisions are taken soon, and the process change is wrapped in 3 to 5 days. Kaizen is a continuous improvement method, whereas the Kaizen Blitz is part of the improving process. Kaizen follows PDCA, in essence, plan, do, and check and act for the improvement process. Kaizen Blitz uses PDCA for execution, where the events are planned, conducted, decided, implemented, and followed up. The following screen will elaborate on the concepts of Kaizen and Kaizen Blitz through examples. Kaizen and Kaizen Blitz are practiced in many organizations across the world. The examples of Kaizen and Kaizen Blitz method are shown here. Click each tab to know more. The Toyota production system is known for Kaizen practices. In Toyota, if any issue arises in the production line, the line personnel cease all the production until the issue is resolved. Once the solution is implemented, the team resumes the production cycle. A wood window company in the state of Iowa, U.S., uses the Kaizen Blitz method to redesign their shop floor and replace expensive, non-flexible automation with low-cost, highly flexible cellular applications. Eliminating scraps, reorganizing work areas, and reducing inventory are some of the examples of quick implementation through Kaizen Blitz.
Let us get some concepts cleared on multivariate charts, a popular tool used by green belts and black belts. Multivariate charts helps you understand within piece, and time variation. These variations are also known as positional variation, cyclical variation, and temporal variation. With the help of multivariate charts, you can clearly identify what is the major source of variation in your process. This variation family has roots in common and special causes of variation, so black belts need not worry about dealing with a new family of variation. Use the tool provided, MVA, in your toolkit to conduct a multivariate analysis. Multivariate analysis helps you to identify the dominant source of variation, that is to say, within piece, or lot to lot. This is a very important tool that is used in almost all DFSS implementations. Pew matrix is a method for selecting a concept amongst multiple concepts by using a scoring matrix and is used in almost all DFSS implementations. The Pew matrix is closely tied to the QFD and is in the form of a prioritization matrix. Options are scored relatively. Score 1 for a solution better than the current solution. Score 0 if the solution is the same in effectiveness, and score a 1 if the solution is worse than the current solution. This method is effective only when you have multiple solution alternatives and you wish to choose one for your project deployment.
Now, if you go to some social media sites, and you went to LinkedIn, for example, you'd find that about 40% of managers in top companies are Lean certified. You'll see that certified Lean Six Sigma professionals earn 40% more than their non-certified peers. And, you know, the majority of quality managers hold multiple certifications. Now, it stands to reason that because the methodology is all about solving critical issues for an organization, that when you empower somebody through the ability to make changes to their organization, when they've got leadership support, and they've got a skill set, the capability to take on those challenges and lead people as part of a team through a project that addresses and permanently resolves a critical issue for that business, that individual is going to be recognized. Not only have they driven value through the organization, as you can see, you know, from Motorola to Ford and so on, but they've proven themselves as somebody that can really get things done. And so, you know, one of the best things that I've personally found through my involvement in Lean Six Sigma over the years is that you're really able to tackle those critical, those big issues and key opportunities that an organization periodically faces and get things done. And that's exciting. It's fun to come to work each day knowing you're going to make a change, have a positive impact, not only on the organization, but on the people around you as well. And so you certainly will be recognized, noticed, and, you know, succeed as a result of that. Now, over the course of the training, we go through 6 different learning units. Now the first learning unit is around providing an overview of Lean and Six Sigma. So a little bit about the history, how did Lean come about, how did Six Sigma come about, what are the methodologies, and what are some of the what's the historical context of each, so that you appreciate that there's been an evolution of sorts from using the methodology and incorporating the tools that we used within Lean Six Sigma to where we are today, where it's a mainstay as a continuous improvement approach for so many different businesses. We move in to define the measure, analyze, improve, and control phases of a project, because it is a project-based methodology. We tackle issues or challenges in an organization, and we put projects together to address those issues. And so you might have heard the phrase or the acronym DMAIC. And DMAIC is really just the acronym for Define, Measure, Analyze, Improve, and Control. It's easier to say, I suppose, than 5 separate words. But through any improvement initiative or any work that we do in an organization, we start out by defining what it is that we want to achieve. It's not a lone wolf activity. You put together a project team, you put subject matter experts around you to work on that issue. You're leading that team, so you're demonstrating and gaining leadership competence, but you're also putting a team of people around, so that helps ensure that you've got the right knowledge, process knowledge, you've got the right set of people to help. It's not all one person having to do everything. You can delegate and so on. And maybe most importantly, you get buy-in from the subject matter experts, because they're part of the solution. They're part of the team of people that are going to be figuring this out. And so in the define phase, you select your team members, you put a project charter together that says, here's the objective of what we're going to be working on. If we're successful, this is what we'll achieve. These are maybe some of the resources we anticipate needing for this project. Here's the timeline that we're thinking that this will take, and so on. So those parameters create the foundation for your project, and it also ensures that everybody's aligned and on the same page and knows what they're working on. As you move into the measure phase, here's where we talk about the tools or the strategies that we can employ to measure and understand our current state. Where are we today as we start this? It takes the blinders off. There's no fooling ourselves, thinking things are maybe better than they really are or worse than they really are. It's about taking stock of what the reality is for our current situation. And so we use a variety of tools or strategies to accomplish that. We make sure whatever information or data that we're using can be relied upon. Just because we run a report or a computer generates a report for us to look at doesn't mean that the information is correct. We have to validate it. Make sure that whatever critical information we're using and making decisions upon can be trusted. As we move through the measure phase, using the tools or strategies to create that current state understanding, we move into the analyze phase, because the reality is this, that we only have limited resources. We only have so much time, so much money, so much energy, so much whatever's important to us. It's limited. We want to make sure that we invest it in the right ways, in the right places, at the right time, and so on. And so because of that, we go through the analyze phase to identify those critical elements of our process that we're trying to improve. Whether we're trying to improve a financial part of the business, whether we're trying to improve a customer-related part of the business, an employee-related, and so on. And so it's important for us to be able to understand those critical elements so that we can invest our resources wisely, because not every element or every component or every piece of that area of the business is going to be equally important. And so if we can invest our resources in the right places, in the right way, at the right time, we're going to get the best return on that investment. And so the analyze phase is about using tests. Quite often we use a lot of statistical tools in this area, and we teach them, of course, through the training, so they become much more intuitive, that you can make that determination. And as we've identified those critical elements where we're going to invest our resources, we move into the improve phase. And in the improve phase, this is about using tools to identify, to test, to maybe experiment, to figure out what are the best ways to go about improving those critical elements. We might pilot something. We might use brainstorming. We might use design of experiments. We might use root cause analysis and so on to be able to figure out what's the best way to not only identify those improvements but also the most effective way to implement them successfully. As we've done that, we move into the control phase because we want to make sure that whatever we've done is sustainable. You know, it doesn't help us if we make a quick improvement and then everybody celebrates and it goes back to afterwards to the old way of doing things. That's not what this is about. This is about permanently changing things for the better. And so it's important for us to be able to use tools or strategies to make sure that the improvements we've generated are sustainable in the long term. And so we can use, you know, statistical process control charts, or SPC charts for short. We can use control plans and so on. And so through those 5 phases, the define, the measure, the analyze, the improve, and control phases, we build upon that foundation or that understanding of what Lean and Six Sigma are all about that we learned at the outset of the training program to truly understand how we can improve the business in the long term across those areas that will deliver the best return. So let's talk a little bit about Lean Six Sigma. Just from the short discussion we've had so far, it should become somewhat evident that it's a disciplined process. You know, it's not about using intuition or best guesses. It's about using information, or sometimes what we can say data. Data is information. Using data to make better decisions. It's a much more robust, much more disciplined way about about doing things. It's also about continuous improvement. Each day we want to get better than we were the day, you know, that we were the day before. And so we don't necessarily have to make these gigantic leaps, you know, every single day, but those incremental improvements over time add up significantly. And so every day we get better and better. And Lean Six Sigma can help accelerate the pace of that improvement. Certainly when you instill and provide, you know, seamless training and resources to people, you instill that capability in your people and you empower them to make changes across those areas of the business that need it and will benefit the most. That's very powerful. And in order for that to be successful, of course, you have to have consistent top management support. And so when the leader of an organization says, look, the way we're going to make improvement across critical areas, those key issues and challenges that we face, is through a more standardized, more systematic, more robust approach, Lean Six Sigma, then that sends a message. And so you need to be able to empower your employees, you need to have that with the capability, and you need to have them supported. Now I want you to think about for a moment a scenario from 2 perspectives. The first perspective is this. Let's pretend that you own a restaurant. And you can imagine as the owner of a restaurant, you work long hours. You probably work 6 or even 7 days a week as the owner. You probably work long hours, mornings, you might work nights as well. You don't get a lot of time for vacation. Now the good news is that you happen to be a member of a local trade association or chamber of commerce or some type of group that has a contest, and you win the contest and you have a 2-week vacation. It's been a long time since you've had a vacation. And so as you can imagine, most employees, when they take their vacation, they're pretty happy, but in the back of their mind, they're wondering about work. And so as the owner of this restaurant, you're going to phone the manager left in charge and ask them for some information because you'd like to know how the restaurant's doing in your absence. What kind of questions do you think you might ask? Well, I think that as an owner of a restaurant, I would probably ask about food sales. I might ask about beverage sales or liquor sales. I might ask about dessert sales, appetizer sales. I might ask about any employee issues or any equipment issues. Just like any manager, any owner, any business leader will want to know how the business is doing across different areas, they probably have a series of metrics. Maybe it's on a balanced scorecard or some kind of a dashboard, but they're usually metrics or measures that that manager, that business leader will want to know to gauge how well the business is performing. You know, there's often a financial or a series of financial metrics. Maybe it's profit, net profit, gross profit. Maybe it's sales revenue. Maybe it's something else. But there are usually some financial metrics, just like there might be customer-related metrics and employee metrics and so on. Well, the reality is this, that they're really outputs, they're effects. In an equation, we could say that there are Y. They're the result of other things. They're They're a byproduct of the activities being performed across the business and how well those activities are being performed. Now let's look at that restaurant from a different scenario, and let's pretend instead of being the manager or the owner, we're a customer. You know, as you can imagine, a customer probably has a choice of a large variety of restaurants, different styles of food, different price points, different types of ambiance. Customer might be interested in the speed of service. Are they there for a long leisurely dinner? Are they on a work lunch? What's the presentation of the food like? What's the quality of the service like? Lots of different things a customer might be interested in and consider when determining which restaurant to select. Well, those are the inputs. They're the causes. They're the things that drive the sales, the customer satisfaction, the employee productivity, the employee engagement, and so on. The results or the effects, those whys, are really a function of those inputs or those causes. And the better we understand and can identify and manage those inputs, those X's, the better we can determine what our why will be. And so Lean Six Sigma is about solving this equation. Wherever we've got a metric or a measure within our business that's really struggling or isn't where it needs to be or could be or we believe it should be, if we can understand what those drivers are for that metric, those X's, we'll say, the causes, then we can focus our efforts on improving those X's by being more surgical in terms of our improvement approach. And our why will take care of itself. Too often we throw things at that why without necessarily understanding what those X's are. And very often when we've got a process or an area of our business that's struggling or suffering or not performing as well as it needs to, it's because we don't really understand what those X's are at all, or we misunderstand what they might be. And so when we solve this equation, we understand what the drivers are, the causes, the inputs to our critical processes, and we focus on those most critical X's, then our why becomes better, and we see better results. And when we work on a project to identify those X's, we, as I started the presentation talking about, typically work through this DMAIC or Define, Measure, Analyze, Improve, Control project approach. And they're really phases of a project. So, you know, we start by defining the problem, the statement. We might say we want to improve productivity from where we believe we are today to some improved level tomorrow or at the end of the project. Maybe it's improving customer satisfaction from where we are today to somewhere else. Maybe it's improving something else. So we define our terms. We determine who's going to be involved in the project, who makes sense to have on the project team. We think this will take so much time, and so on. So we set the foundation, we align our goals, we all understand what we're working towards, and so on. We collect data as we move into the measure phase to understand, you know, what the current state really is. We create a process map to understand the elements and the steps, the pieces of our project. We determine through the analyze phase which are the most critical elements of that process. Once we've done that, we can identify, prioritize, test the improvements, and we set up a control plan towards the end to make sure that going forward our improvements will be sustained. Because the project team that we're working with isn't a permanent fixture. It's probably a group of 4, 5, 6, 8 people that will work on this project until we've achieved some goal, and then it disbands. And so it's important for this team to leave behind this legacy saying, here's a more robust way, here's a control plan, we'll say, to make sure that the people involved in this process know how to manage it effectively so that the gains that we've been able to achieve through this project are sustained and perhaps even continue to be improved upon. Now, it stands to reason, of course, that the team members are often people that are involved in that process in any event, and so they'll be involved going forward. Just maybe not in a more formal sense that, you know, we had a project team before and they were focused on this effort, and then, you know, you move on and you go back to, you know, your regular roles, but the elements of that process control plan stay in place, and so the new normal, the new way of doing things is much more clearly laid out for you. Now, as we go through those different phases, the define, measure, analyze, improve, control phases, and we talk about tools or strategies, this is a small sample of some of those tools or strategies. And so as an example, SIPOC is just an acronym, stands for Supplier Input, Process Output, and Customer. And it's a way of visually mapping out the steps of a process. And when we map out those steps of a process, we look at each element of the process, who's the supplier, what's the supplier for that element? What's the input? What's the process step? What's the output or the result? And who's the customer for that element? It's a very good visual that helps also scope the project from its starting point to its ending point, because you want to make sure that everybody understands the things that are happening today. And very often what will happen is you'll have multiple people on the team saying, gosh, I didn't know that's what happened after my involvement, or I didn't know what happened before my involvement. When you start having those conversations, people can often identify some quick hit improvements, saying, well, gosh, if I had have known that, then I could have done this differently. And so that's often a very valuable exercise as you're starting your project. VOC, voice of the customer, CTQ is critical to quality tree, quality function deployment, and so on. So these are acronyms. And as we go through, of course, these will become much more familiar for you as we talk about them and teach you how to use them. Now, you'll notice that some of the tools are listed in multiple places, and it's because there's no set rule that says you must use an FMEA or failure modes and effects analysis tool only in the define phase. These tools were not designed for Lean Six Sigma. They were designed to solve specific problems, and very often they were developed or designed or invented within organizations and considered proprietary. They were trade secrets of sorts at, once upon a time. And so, because they were invented or designed to solve a specific problem or answer a specific question, if that problem or question happens at a different phase of the project and that's the right way to solve it, then you use the tool that's appropriate. Now, very often you'll use, the SIPOC map very early on in the project, just like, your voice of the customer. It makes sense to use it very early on so you understand what your customers want as soon as possible. You're not going to do your VOC at the end of the project when you might find, well, gosh, they wanted something completely different. You want to do it on the front end. So you make sure you align what you're doing with what your customers are looking for. It stands to reason. Now, Lean Six Sigma is going to be successful for the following reasons. When management supports Lean Six Sigma as a business strategy, it says, this is the way we're going to make important decisions. We're no longer going to rely on gut feel or intuition. We're going to use a more robust way to make important decisions. So we rely on information or data instead. It uses that DMAIC methodology for solving problems. That's a very logical, very straightforward, makes a lot of sense. Let's define what we're looking at. Let's measure where we're at today. Let's analyze to figure out what's important. Let's figure out what we're going to do about it, the improvements, and then let's make sure that we can control it going forward. Very straightforward, very logical, makes a lot of sense. And we, of course, incorporate the tools or the strategies within that framework or within that DMAIC methodology so that we can answer the questions we need to move forward. We have well-defined projects that directly impact the organization's bottom line. Now, I will expand on that by saying that what's really important is we work on those issues that are important to the organization. Very often, they have a financial component. Certainly, when you can argue that this project will deliver, this many dollars or this much money to the organization's bottom line, that becomes a compelling argument for the project. However, there are often times when an organization will take on a project because of some other reason. Maybe they're trying to mitigate some long-term risk. Maybe they're trying, here's an example, I worked with an organization that really wanted to be a good community citizen, really good corporate citizen. And they partnered with different charitable organizations in their community, and periodically we do projects for them. Didn't necessarily help the business's bottom line, but they did it because they believed it was the right thing to do. Often, Lean Six Sigma will help increase customer satisfaction. In fact, I would say that virtually every project you do in some respect has an impact on your customer. And very often it also helps use statistical methods. So we'll require the extensive use of statistical methods. So for example, if we look at our measure at the beginning of a project and we say here's how well we were performing when we started, at the end of the project now here's how well we're performing after, we can run a test to determine whether or not that difference is likely to have happened by chance. And we would we would, most instances find no, it isn't by chance. It's because of the improvements we put in place. But it's not just us saying, hey, things seem better, people seem happier, customers seem better, I think we're making more money. It's not a soft statement like that we're making. We're able to demonstrate through numbers saying that, yes, we've made a meaningful change to the business. Now, some key terms that we would want to look at and talk about as we move forward. Now, we keep saying the word or the words Lean Six Sigma. Now, you might be wondering, well, what is a sigma? Well, a sigma is another way to say the standard deviation of a process metric or a measure. Now, you can imagine if we have some type of a measure in our business, and maybe it's profitability, maybe it's customer satisfaction, maybe it's employee productivity. Whatever that measure is, we don't simply take one measure at one period of time and move on with it. We probably take it over a period of time, and there's probably some variation. Not every customer gives you exactly the same customer satisfaction score. Not every transaction delivers exactly the same amount of profitability, and so on. So there's some variation. Well, standard deviation is the average amount of variation about the mean, or the average. Mean's another way to say average. And so we can look at a process and the variation across that process over time, and we can measure that. And we know in a normal bell-shaped distribution that if we were to take a look at that over, let's say, I'll make up 6 months or a year, it could be any amount of time, that about 68% of all the results will fall within one standard deviation. About 95 will fall within 2, 99 will fall within 3, and so on, all the way up to 6 sigma. Well, with 6 sigmas of variation, 6 standard deviations of variation, it's going to capture about 99.99966% of all expected values. Now, when we can ensure that a process is delivering within customer expectations or customer specifications at the 6 sigma level, what we're really saying is that if my customer wants this product, this service, this whatever, and here are their parameters and how they want it, and we can consistently deliver that 99.99966% of the time, 6 sigma, then that's how good we are. And so we want to be able to deliver flawless performance. Now, when we look at an opportunity, it's really just you either do it right or you do it wrong relative to customer expectations. And when you do it wrong, we call it a defect. A defect, another way to say this, is that when you fall either on the lower side or the upper side of customer specifications, it's a defect. Now, to put this in plain language, if I go into my local Starbucks and I order a cup of coffee, I like my coffee to be a certain temperature. And so the company might say that, and I'm going to make up some numbers here, if that cup of coffee, and it could be tea, it could be whatever, is within 60 to 70 degrees Celsius, that's just the right temperature. If it's less than 60, it's too cold. If it's more than 70, it's going to be too hot. So my spec limits might be within 60 to 70 degrees Celsius. Anything outside of that is a defect. Our goal, of course, is to consistently make that cup of coffee within spec. It's up to the customer to tell us what those specs are. If they can't tell us, we need to figure it out, because that's what will make them happy. I might not be able to say that I want to be able to get in and out of a drive-through in less than 3 minutes, but the business might be able to run a test and figure out that, hey, our customers, as long as they get in and out of a drive-through in under 3 minutes, they give us really high recommend scores. When it takes longer than 3 minutes, the scores go down dramatically. And so sometimes a business will have to go out and figure out what their customers want. What is that voice of the customer? And then be able to figure out how to deliver that consistently. Now, very often what happens is that an organization will have, a process in place, and each individual within that process will think that they're performing pretty well. In fact, I've gone into groups where I've asked people to put up their hand if you think 90% is good. And most of the time, almost everybody puts up their hand. Well, you can imagine that if you've got a 3-step process, which would be pretty simple, pretty straightforward process, 3 steps and you're done. Well, let's say at the very beginning of the process, I give you 100 units. First person does their thing, and 90% are good, so 10 are scrapped or have to be reworked, but 90% get to move on. And they're pretty happy. They're 90% good. Well, the second person now gets that 90%, and they're 90% good, so 90% of that 90% gets passed to the third person. That's 81%. The starting point for that third person is only 81%, and they're doing 90% of that. It goes down even further. When you've got multiple people involved at each step of the process, you get more and more waste involved, and that becomes very expensive. Not only does it cost a lot in terms of scrapped or reworked product or services, customers don't get what they want, they have to pay more, presumably, because the company is not as efficient or as effective as they are, and they're either absorbing the costs or passing them on through higher prices. Customers may have to wait longer. It's got to be frustrating for the employees. It's a bad deal. And so roll throughput yield is one way to look at that expressed as a percentage. It's a way to look at process efficiency expressed as a percentage. Now, I mentioned earlier on that, at the Six Sigma level, we're 99.9996% good. Well, another way to look at that is defects per million opportunity. At the Six Sigma level, we'd only produce about 3.4 defects. Now, that sounds really good. In fact, if I said I was 99.379% good, most people would be pretty happy with that. In fact, I think most people would be pretty excited. They'd be putting up banners that, hey, I'm 99.379%. But for every million opportunities for a defect, they'd produce 6,200. Anybody want to get on a plane that's at 4 sigma? I don't think so. There are some processes, there are some things that organizations do that are so critical that you simply can't afford to be anything but flawless. Now, if I'm manufacturing, something that, I'm serving popcorn or something that's much less critical, then maybe I can afford to be a little more cavalier with that. But we have to look at our organization and say, for those critical processes, how good do we have to be? And this is the way we go about getting to be that good. And when you can implement Lean Six Sigma and you can put it into place, some of the benefits, they're so widespread. When you eliminate the root causes of problems and defects in a process, you create robust products and services, you reduce process variation, you're going to achieve all kinds of benefits for your organization. You help ensure customer satisfaction. You can reduce rework by getting it right the first time. Imagine what that does to employee engagement, morale. When you set your employees up for success and they go in each day, they have a better day. And because they have a better day, you have lower turnover. You have happier customers. You have lower costs. It's a win-win-win for everybody. And you can see that the benefits aren't necessarily strictly financial or strictly customer-driven or strictly about employees. They go hand in hand. When one benefits, they all seem to benefit. They all seem to work in conjunction that way. I've never talked to someone that said, I went home at the end of the day yesterday because I had, had such a hard day, I was just too productive. You just don't hear people say that. You hear them say instead that I went home at the end of the day and I said to my family that I had a hard day, and then they talk about the problems or the obstacles that got in their way. Well, when we can remove those obstacles, those problems, we can enable people to be productive. They have better days. You have higher morale, better engagement. They're happier. Customers are getting what they paid for as well. And the company's incurring lower waste and expense because you have all those benefits as well. Now, the history of Lean Six Sigma is interesting because I mentioned earlier on that none of these tools or strategies that we talk about were developed or invented for Lean Six Sigma. In fact, the methodology really came about back in the 1980s when a reliability engineer by the name of Bill Smith, working with Mikkel Harry at Motorola, put together the program because they wanted to get from where they were, where a lot of their products were defective and they were having a lot of challenges and issues. Their competitors were simply getting better than they were. And they developed this methodology. Now, coincidentally, some of the members on Smith's team happen to be karate enthusiasts. They recognized the similarity between the discipline that they were looking at employing through the Six Sigma thing that they were talking about with karate, and so they called themselves belts, hence, green belts and black belts. That's where it came from. Now, Motorola went on to win the Malcolm Baldrige Award in 1986, the inaugural award. Malcolm Baldrige was a Secretary of Commerce at one time in the United States and a big proponent of quality. And after his death, they named this very prestigious award in his honor, and Motorola was the inaugural winner. And because of that, word started to get out, and people started saying, hey, what are you guys doing? And people started talking about this Six Sigma. Jack Welch at GE got on board sometime in the 1990s. Allied Signal got on board. Today, the vast majority of Fortune 500 companies use Lean Six Sigma. You see a proliferation across, smaller and smaller organizations as well happening. So small and medium enterprises are adopting it. I've certainly seen a number of cities and municipalities and government agencies adopt Lean Six Sigma. It's a very powerful, industry-neutral methodology that enables an organization to transform itself from the old way of thinking, let's rely on gut feel or intuition, or whoever is the most authority gets to make the decision, to instead relying upon data. Let's use the information to guide us to make our critical decisions. And when you do that, it changes the nature of the way an organization operates and functions and thinks about solving its problems. And as some of these examples on the slide that you can see, the savings are incredible. You're seeing these organizations saving millions and in some cases billions of dollars because they're driving waste and inefficiency out of their system. Now, there's no one single model that says this is the only way you can implement a Lean Six Sigma team. However, this is a very good overview of what most successful organizations look like. Whether they call these roles by these names can vary, but essentially they function as outlined here. So, you'll have top executives that will lead the change and provide direction. They ultimately own the Lean Six Sigma initiatives, because if they're saying, our goals for the organization are, here's around profitability, here is around, customer satisfaction, want to be the first choice of customers, here's around, employees, and so on, then they know where they need to focus their efforts. And so they can say, we need to improve in these areas. They have that broad oversight and visibility to not only where they are today, but that longer term vision, so they can align the two. You'll have Six Sigma champions. They'll help identify and scope projects. They may be, they may not be C-suite executives, but they might be vice presidents or senior leaders that will help identify as well the projects that will be worked on. They have that visibility as well. They're connected that way. You'll have Six Sigma Master Black Belts. They're the functional leaders of the organization. They'll train other functional leaders as well. They'll train and coach black belts and green belts. They're the technical experts in Lean Six Sigma. They may also take on some broadly scoped projects or strategic projects in nature. And then you'll have both green belts and black belts. Now, black belts and green belts in some organizations will be determined in terms of the time they spend on projects as well as the scope and complexity of those projects. So a black belt, for example, might be a full-time resource. That's what they do every day. They work on Lean Six Sigma. And they can work on Lean Six Sigma across the business. It's a very, very good leadership development approach as well. When you take some of your best employees, you train them in Lean Six Sigma, and then you let them work on projects across the business, that's extremely powerful as a development strategy. Green belts tend to work on projects that aren't necessarily as complex or broadly scoped as black belts. They may or may not be full-time resources. So, for example, they may say, well, gosh, I work in HR or IT or operations or finance or engineering or wherever, and I want to work on projects within my area of the business. And so they'll work on it more on a part-time basis. So some percentage of their time might be devoted to improvement work. Now, of course, it varies from organization to organization how they define, green belts and black belts and so on. But this is a very common framework. Now let's talk about an example of one of the lessons that we would talk about. And this one comes from Overview of Lean Six Sigma. So at the outset of the training, the first day, for example, we would talk about this. And topic number 3 happens to be about Design for Six Sigma. Now, Design for Six Sigma, or DFSS for short, and I guess DFSS is a lot easier to say, it's not quite the same mouthful. When we've got one of two situations happening, Design for Six Sigma is really the approach that we take. When we've got a process or a product that is too badly broken to merely fix, it needs to be instead redesigned or a new one developed, invented of sorts, then DFSS is a very good approach. Alternatively, if we are trying to create to an existing product line or service, then we might use DFSS as well. One of the tools within the DFSS framework is the Failure Modes and Effects Analysis, or the FMEA for short. Now, the FMEA is a very good preemptive tool that helps identify potential ways a process might fail. Now, when we work through the FMEA, we're going to calculate something called a risk priority number. And it's simply a measure of risk that we can assess that would be associated with that design or that process. And the risk priority number is the result of looking at a potential failure, and that potential failure has been looked at through 3 different lenses. The first is the occurrence. How frequently does it occur? Severity, how bad would it be if it did occur? And detectability. What is the strength of our detection mechanism to stop that failure from happening in the first place? And so when we look at each element of a process and we say to ourselves, or our team rather, how frequently do we think this occurs? How bad would it be? What's the detection? We score those on a scale of 1 to 10, 10 being the worst, the most severe, the most frequently occurring, and so on. Multiply those scores by each other, we get that risk priority number. Now, we can use the FMEA on either a new process that we're designing or an existing process for that matter. It might look something like this, where we'd say, what's the process step? What's the key process input? In what ways does the key process input go wrong? What's the impact on the output variable, the customer requirements? How is the customer impacted if this fails? How severe would that effect be on the customer? What causes the key input to go wrong? How often does it occur? What are the existing controls and procedures that might prevent the cause or the failure from happening? And how well can you detect or prevent that failure mode from happening? And then when you take the severity on a scale of 1 to 10, occurrence and detection, you multiply, you get that risk priority number. Now, there are scales that we can use, and I would suggest that you can certainly use this exact scale in the language that's used here, or you could go through your project team and calibrate them and say, well, look, with 10 being the worst on a scale of 1 to 10 for severity, how would we want to word that? And maybe it's catastrophic. Maybe it's, something else. It's important to make sure that everybody on the team that's going to go through and use this rating understands what the language means. And if hazardous without warning makes perfect sense to you, then that's great. Use this language. But again, if it doesn't, then what would a 10 be in your world? What would a 9 be in your world? And so on. For occurrence, similarly, we've got a scale here. Same thing in terms of, does this language, do these numbers make sense for you? And our detection score. Absolute uncertainty, there's nothing in place at all today. Very remote, there's a very remote chance the design or the process control would detect potential cause or mechanism subsequent failure mode. There's really very little in place that would prevent it. Remote and so on. And so here we have an example, and let's pretend that we're a bank manager. And as a manager of that bank, we recognize that very often we compete on our rates, and we're saying, well, gosh, that's a pretty tough way to do business. And so what we're going to do is we're going to make sure that we provide great customer service. We want to make sure that our customers can depend on us. And so let's look through the customer satisfaction scores over the last period of time, let's say 6 months, and look at the different things that customers have said about us so that we can identify those areas of the business we need to improve the most. We've done that, and one of the top items happened to be when people take out money or cash withdrawal from the ATM, the customer's account's debited but cash is not paid. In other words, you see the slip that your balance has been reduced by whatever you tried to take out but didn't dispense any cash for you. So you're going to be pretty unhappy, extremely unhappy even. In fact, on a scale of 1 to 10, you might say, gosh, that's a 9. You might say as the project team, well, what are potential ways that this could, happen? Well, maybe there's non-availability of cash in the ATM. Machine ran out of cash. Maybe there was a network issue. It thinks you gave the cash, but it didn't. How often does it occur? Well, the team believes, based on their research or their experience, their training, Then on a scale of 1 to 10, the first one's a 7, the second one's a 5. Now just break at this point to mention that we haven't gone out and validated the data yet. This is a tool we tend to use early on in a project because we probably have quite a large number of customer complaints. We want to filter down to the ones that are most critical for us before we go out and start collecting hard data and measuring and actually testing and so on, because that'd be potentially it's time consuming. And so this is a preemptive tool in that sense. It gets us very close to those issues that are most important, and so we're still using and relying on the subject matter experts on our project team at this point before we actually start going out and measuring and collecting data. In any event, going back to the FMEA, we've taken those severity, occurrence, and detection scores, we've multiplied them by each other, and we've gotten 112 and 405 respectively. And I will say that I see that current design control has been given none, and they scored that a 9. I'd personally give it a 10 because if you've got nothing in place, it doesn't get any worse than that. So, it's a judgment call, but this team gave it a 9. Now, as a project team, you'll probably put together some recommended actions, which they've done. You might assign responsibility and target completion dates. They've left that a little bit vague. Now, we'll come back to this at the end of the project and we'll rescore this because the project was about identifying those critical areas. Let's pretend that we went out and we verified that, yes, in fact, this is happening a lot. It's not just that we hear about it because those customers that this happens to are the loudest. These issues really do happen a lot and they need to be addressed, and so we've addressed them. We've put improvements in place and we have come back to the FMEA to rescore to test to see how effective our improvements are. Now, the team has said, well, gosh, if this happens, it's still a 9. The difference after the improvements have been put in place at the end of the project is that they're really not happening very often at all. We've gone from occurrence of 7 down to a 4 and from a 5 down to a 2. It's because our detection mechanisms are far more robust. They're much better. In fact, we've gone from a 7 to a 1 and a 5 to a 3. And so our risk priority numbers have decreased tremendously as well, from a 112 to a 32 and from a 405 to a 54. So we've revisited this and we've said, okay, based on the improvements we've put in place, they've been very effective and we've been able to improve the business as a result, and customers are much happier with us as a result of this as well. Now, this is just one small example of a tool that we talk about in Lean Six Sigma, and we would certainly go through it in more detail. We've got the template for you that we would work through as well, so you'd gain an even better understanding of how to use this tool and in what situations and circumstances it could benefit you. Now, we do that through more than 57 hours of training in Lean Six Sigma. We talk through different industry case studies and more than 100 real-world examples. You can attend batches on weekends or weekdays or whatever makes sense for your schedule. There's on-demand support with dedicated team and Simplilearn community, so you can reach out and talk to others. There are guest lectures, and there's training by industry experts, people that have done this and used the methodology in the real world and can talk about their experiences. Now, here are some of the upcoming batch dates. As you can see, they are during the week and evenings and weekends as well. So whatever makes sense for your schedule, there's availability, so you can select a batch that makes sense for you. On that note, I see we have a few minutes left that I'll open it up for any questions that you might have. I think I can see your questions in the chat box if you have anything you'd like to ask. Alternatively, you can also send a note through to Simplilearn directly, or go to the Simplilearn community and query there. About the RPN being 126 instead of 112. Let me take a look. Just like 9 times 5 times 9 should be 405. I haven't done the math manually, but thank you for pointing that out. How do we get 32? Here, let me just minimize this so I can see. Yeah, we've gone back through this again. So, we'll use the FMEA at 2 points in the project. We'll do it at the beginning or early on in the project so that we get a sense of, we might have 25 or 30 elements of a process that we're looking at, some larger number. Well, that's a lot of stuff to go investigate and test. And so this FMEA is like a filtering tool where we can go through this with the subject matter experts. They say, they'll come through and we'll calculate these initial RPNs. Some of them will be, like 405 is pretty high. Some will be much lower. I don't know if 112 would be particularly high on most FMEAs, but we'll say it is this example. Well, we're not going to go investigate everything, nor are we going to address everything in this project, because there may just be too much stuff there. And so we'll prioritize it based on the RPNs. Those RPNs the team believes are critical enough that we move forward with, we go and we collect data for. We validate what we thought was happening. We'd actually go measure this and test this to see if this is really happening. And if so, then we develop and implement improvements, and we make sure that they work. And we come back and we visit the FMEA at the end to make sure that, that they've had the desired impact. And so we would rescore it at that point. And so at the end of the project, after the improvements have been put in place, we'd say, well, if it happens, it's still just as bad because it is. The difference is that it's not happening anymore. It used to happen a lot, and now because of the stuff we've done, it just doesn't happen very frequently.
So let's review what is the definition for Lean Six Sigma. So in recent years, there were two methods that of improving manufacturing processes have come to the front, that are basically Lean and Six Sigma. They were used to solve two different types of business problems in the past. But today, Lean and Six Sigma are integrated into one methodology and toolset for solving any process problem in any type of organization, from Fortune 500 companies to small private business to nonprofit institutions. Believe me that this is something that is real. I've been using it in any kind of company, very small, from just one person to big companies like Coca-Cola. So Six Sigma improves the quality of manufacturing outputs by using statistical tools to minimize the variations. On the other hand, lean manufacturing is a production process that eliminates waste, thereby increasing the endpoint value for the customer. So both methods have been used successfully by large corporations in the United States, in India, and in Japan, in any part of the world. So the real truth is that at the very beginning, Lean and Six Sigma both started in the manufacturing side. Six Sigma is a philosophy of process management developed by Motorola in the 80s that uses statistical methods to minimize errors. Over the long term, manufacturing processes tend to deviate from the standard, so Six Sigma is helping to reduce that deviation. In the case of lean manufacturing, it began in Japanese manufacturing after World War II crisis. Eiji Toshoda and Taiichi Ono from Toyota, the car manufacturing company, went to visit American plants because they were in crisis. So they organized their learnings in a new system called JIT, or Just in Time, which later was called as TPS, or Toyota Production System. But that system was a bit late behind. After, like in the 90s, James Womack, an American guy, wrote a book about this new methodology to be used in any plant across the world, not only manufacturing. And he called it lean manufacturing. Its basic usefulness is in providing the tools to identify and eliminate waste throughout the manufacturing process. So this is how Six Sigma started and lean manufacturing started. So what is Lean Six Sigma together? Together, Lean Six Sigma is a systemic approach to improving the way people do process improvements. There's a methodology that is involved that allows them to systematically enhance your process. Business are really in business for two reasons, right? One is to satisfy the customer, and the other one is to make money. So bear always this in mind. You have a systemic approach to improve processes and to satisfy the customer. Today, what we're going to see is how this systemic approach works. And of course, we're going to see what are the benefits. So let's move to the next slide. One of the benefits is increased employee involvement. Increased employee involvement is one of the big benefits of Lean Six Sigma. Through their participation on process improvement, teams designed to help them improve processes and increase value for their own customers. So people get really, really involved because they actually can see how they can help their company to improve what they are doing, to improve the processes and to improve customer satisfaction. So by involving employees in the implementation of these programs, they gain a greater appreciation for the impact of the work they do on bottom line business results, as well as an appreciation for how the work of other employees and departments also contribute to success. So this is one of the key benefits. The second benefit is that you have reduced cost. One of the primary desired benefits is a reduction in cost associated with improvements to process to require less time, to decrease defects or errors that can result in work. By examining the various steps involved in a process, understanding what customers value, and the taking steps to eliminate unnecessary steps, you can also increase value for the customer, but also you will be reducing all your cost. So you can see you can save like from 20 to 50% of your cost. That's a great thing. But as I said, you are not only going to involve your employees and reduce cost, but also you will be increasing customer satisfaction. So Lean Six Sigma methodology involves a strong focus on customer needs and delivering high value to them. So you will not only focus on the process, but also you will also focus on how the customer is going to receive your product and your service. And of course, ultimately, increased customer satisfaction will lead to repeat business, increased positive word of mouth, and with successful implementation, you will also increase sales and, of course, overall business success. So, what is that customer wants? Customer wants everything, right? We always see if you always see customers within your business, you may be the owner of the business, you may be just one of the employees, but customers want everything. So Lean Six Sigma, in the end, is a systemic process to continually improve what they want, which is quality, cost, and delivery time. Whatever the product or whatever the service, all customers are looking for these three aspects. Faster, that would be a reduced cycle time so that they can get the order much faster. They want it better with improved performance, of course, better quality. And what's more, they want it cheaper or less. So Lean Six Sigma will help you know these matters. So let me show you now. This is the DMAIC methodology. This is the famous DMAIC toolkit that is similar to the one used just for Six Sigma. Lean Six Sigma projects comprise aspects of Lean's waste elimination and the Six Sigma focus on reducing defects based on this DMAIC methodology. The DMAIC toolkit of Lean Six Sigma comprises all the Lean and Six Sigma tools. The acronym DMAIC is the project flow of every Six Sigma effort and represents define, measure, analyze, improve, and control. That will be defining the problem, understanding how to measure the effect of the project so you can see how you are and where you want to be. Third step is analyzing the process through experimentation. Then the fourth one, once you know what is that you want to improve, you just have to go on and improve the process based on the solutions and putting controls at the end in place to maintain the improvement. So where is Lean in this DMAIC process? Lean is basically on the I and C of the DMAIC. It's basically part of the improve and the control, as you will see later on. Moving to the next slide, you will see a chart with the DMAIC tools. This is the table shows some of the Six Sigma tools, of course. It's not imperative to use every tool on every project, but here you can see a wide range of tools that you can use in each of the steps. Again, you can use some of the tools in various of the steps. For example, you can use For example, the brainstorming, which is a very common tool in the measure phase. You can use it in the analyze phase, or you can use it in improving. It's all up to you. The tools are for you to use whenever you want them. You just need to learn which tool is the best for each part of the process that we need to develop. And of course, we have the Lean tools. As you can see on the slide, Lean tools have a lot of five base objectives, which is to seek perfection, allow customers to pull, create flow, identify the value stream and eliminate waste, and finally standardize and visualize customer value. Okay, this is the well-known house of quality of the house of Toyota production system, which the roof of the house is Kaizen, the Japanese word that stands for continuous improvement. So what we're going to see today is where are we going to use all these tools, like the one-piece flow, the TPM, 5S, or the Visual Factory, considering the DMAIC methodology. Well, before we start with the DMAIC methodology, just let me tell you one last thing, which is the training. The training for Lean Six Sigma is provided through the bell-based training system, which is very similar to the judo one. So depending on the amount and complexity of the tools that every employee is trained, personnel are designated as white belts, yellow belts, green belts, black belts, and even master black belts. Again, very similar to judo. Black belts tend to be project leaders, while green belts usually are project team members. So this is the famous DMAIC, and this is all the steps that we're going to see today. Let's get started with it. Define. This is the first step of the DMAIC methodology. So, what are the outputs for the define phase? You have to define the product or the service, you have to identify your customers, you have to define the process, and you have to understand the customer requirements. So this is a phrase that I like very much, which was said by Joseph Duran, one of the main gurus of quality, which says, all improvement takes place project by project and in no other way. So this is the way that Six Sigma and Lean start getting together, having a project. So the first thing that you have to do to start using the DMAIC methodology is having a project to work on. You have to look at your processes and see what's going wrong, where are customers complaining, or where are your employees complaining that they have to work too hard or they have to work too fast and it's not okay for them. So when you have some kind of issues or where you're having a lot of cost that you would like to reduce, well, there you may have a project. So once you have defined your project, the next step that I would recommend to do is to use a cycle diagram. The cycle diagram is useful to see the big picture and define where it ends a process and where it starts. So now we are getting closer to what a manufacturing company is, right? So let's see what is the process of a bottling company, for example. The cycle stands for suppliers, input, process, output, and customers. So the first thing that you need to do with your process is to understand it. How you understand it? The first thing is to define which are your suppliers. You need to see that every task that you do has something that starts before and something that starts after you finish your process. So the best thing that each of your employees need to know is how their processes are connected to other tasks of the other people in the company. So we have our process for bottling, and the process for bottling has suppliers. It may be a bottling company, or it may be employees. the supplier and employees provide inputs. Those inputs are bottles, juice, receipts that will enable me to bottle the juice in the bottle. Then, once I finish the process for bottling, I have the output, which is the juice bottle, and the customer, which is the distributor, which is going to distribute my juice, or the employees that may drink it. So, what about the process itself for bottling? Well, you just have to write all the tasks that are related to your process. In my case, would be first clean the bottles that have been received from the supplier, pour hot juice into the bottles, close the bottles, invert them so that the juice gets to all the part of the bottle. Then you have to cool it down. Then you have to label it, and then you pack it. Once you finish all the steps, you are ready to have the juice bottle and distribute it. Okay, so this is the first step so that you know exactly where to start. Now that you know what comes after and what comes before your process, you have to move a bit deeper, which is going to doing a flowchart. The flowchart is a pictorial representation of the sequence of steps in a process. It's very similar to what we have already done, but it's more detailed. So in this kind of process flowchart, I have included also not only the steps, but also the responsibles for each of them, which is operations, purchases, and reception in this case. So the flowchart, the basic usefulness of the flowchart is that you develop a common understanding of a process. What, who, when, where, and how. This way you also identify improvement opportunities. So this way you can see if there are problem areas or inefficiencies, or if you have redundancy, if you have recycling, if there are gaps between the as-is and the ideal. So flowcharts are very useful for you to see what's going on in your process, and it also will help you to standardize how work is done. Flowchart is also very useful to train your employees, also to document the process. So this is one of the very, very first tools that you need to use as a green belt or black belt. So now that you have defined your process and you have defined what is that you are going to have as an output of your process, you have to measure how it works. That's the second step of the DMAIC, which is the measure phase. The measure phase allows you to understand the before present condition of the process before you attempt to identify improvements. Because the measure phase is based upon valid data, it eliminates guesswork about how well your process is working. Because sometimes you say, yeah, my process is working well, but can you actually say that it's working well? Do you know what is the profitability of the business? Do you know the cost that you're having? Do you know the cycle time? Well, if you don't know that, you are not sure if your process is actually going well. Or maybe it's going quite well, but it could go better. So, first that you need to do is try to define which is the process output measures that you want to have. What is that you want to measure? You have to have a performance measurement, and you have to identify the gaps with the ideal process measurement. This is another very nice phrase that I like to use, that is, if you don't measure work processes, you can't possibly manage them. And that was said by Bill Hewlett. And this is very right. As I said before, if you cannot measure what you're doing, it's very, very difficult that you can manage it, because the only way to show your employees that something is going wrong, that people is complaining, that the manufacturing process is very slow, or is very cost effective, or is not cost effective, then if you cannot tell them the truth, you cannot tell them numbers, well, you cannot actually make them change anything about it. So the first thing is that you have your process flowchart and start measuring how it's working. So one of the measurement tools that I can use is to actually go and count or measure what you're doing. So you have your process flowchart, and then you first need to request materials. So you have to request a quote to suppliers. So measure how much time you spend requesting quotes to your suppliers. So let's say you spend an hour. Okay. But then the next step is selecting the supplier. How much time do you spend until you actually select the supplier? But sometimes it takes, like, for example, 3 days or a week or 2 weeks. So this is a very important phase of your DMAIC methodology. You actually need to know all the time that you're spending, not only by doing something, but also all the time that you're spending doing nothing, like waiting for someone to select suppliers, waiting from the supplier to get you the supplies, waiting for getting the stock actually on the manufacturing plant. So first, measure everything you can about your process. Once you have measured how your process is going, then you can analyze or move to the next step where you can see why you're not getting the results you want. Why is it that I'm getting my supplies for bottling my juice in 2 weeks if I want in 2 days? Well, that's what we have to analyze. We basically, in the analyze phase, what we're going to do is understand why we're going to have these gaps. So the first tool that we can use to analyze is the brainstorming, the one that I mentioned before, which is a technique for generating a high volume of ideas on any topic. So you can use this to stimulate creativity within your team, to encourage any participant to build on another's ideas. You get all the team members involved, because the brainstorming session, basically what you do is have a facilitator asking for team members to look for new ideas. You just have to show your problem on a chart, on a screen, and then team members need to tell what they think it's the problem about them. Okay. Brainstorming is a very important tool, and it's very simple, but it can be used together with other tools like the fishbone diagram, which is the next tool. The fishbone diagram is a brainstorming tool designed to identify possible causes of a problem. It's also known as a cause and effect diagram or a Nishikawa diagram. So what you can do is just, as you can see on the slide, just show on the screen what is the problem and start looking for the different causes, the different root causes. Okay. So what we do on the fishbone diagram, you can just set like spines or categories that are commonly used, or you can use your own. The ones that are commonly used are what is called the 6 M's, which is machinery, methods, material, people, environment, and measurement. So as you can see on the next slide, this is a nice example of how you can use the fishbone diagram to analyze the causes of your problems. For example, in this case, we have long buying time. So why you may be having a long buying time? Because of your methods. If you go to the methods, it's fine. Because retrieving from first floor takes longer. Another option, substitution takes long. Let's say this is a clinic that you are looking for buying things. Doctor is too busy to pick up the phone. Okay, let's go to the person spine. Maybe people is busy retrieving because it's not immediately available for counseling. Maybe people is young and inexperienced. So this is some parts that may be affecting what is going on in your process. So what's good about the fishbone diagram is that you'll see in just one slide a lot of root causes. You just have to keep asking why, which is another tool, the 5 whys. Keep asking why something is going wrong. So why is that we have the problems with the methods? Again, why? Because retrieving from the first floor takes longer. Why retrieving from first floor takes longer? Then you keep answering why until you get to the 5, and then you are going to get the right answer. What you're going to get with this is a lot of, as I said before, a lot of root causes that you have to analyze. Then with your experienced team, which will be people from different sectors in the company, from different areas, even you can include suppliers or customers, they all can vote and see which is the real root cause for the problem. Another tool that you can use to analyze well the information that you have is the Pareto chart. The Pareto chart is very well used if you have real data, for example, waiting time, or if you have information about how much cost you're having. Well, the Pareto chart is a form of bar chart that helps to identify problems by displaying them in a descending order of frequency or size. So, the Pareto principle is founded on the observation that in many instances, just a large percentage of problems are caused by only a small percentage of the total contributing factors. So that is, here, you will have like 6 or 7 categories of problems. But if you just focus on the first one, which is going to have the 80% of the problems, you will only be solving one of the causes. Okay, so just you solve one of the causes and you will be resolving 80% of the problems. The principle was established by Wilfredo Pareto in the 19th, and he really studied that this was the 80-20 rule, and it's applied to any kind of industry. You just have to check your data and see where you get the 80% of your problems. So now you have built your fishbone diagram, you have a lot of causes, then you have analyzed your causes, and you have get data, then you got your Pareto chart to try to prioritize which are the causes that you got. And then you get that one of the causes is the most important about it. So how you solve it? You need to work on the improve phase. On the improve phase, you will innovate, look for solutions, and test them. Test them in just a pilot area. That's the most recommendable way of doing it. And if in that pilot area it works, then you can implement the solution across the company. So here in the improve phase, as I said before, is where we're going to start using the very lean tools. So these lean tools are going to help you basically to reduce the 8 waste that every company can have. The 8 waste are non-value-added activities, which is any effort that doesn't create value for the product or the customer needs, that needs to be eliminated or reduced. Those 8 wastes that you have the acronym for downtime are defects, overproduction, waiting, non-value-added processing, transportation, inventory, motion waste, and employees' unutilized skills. So, lean tools will help you eliminating all these 8 waste. And the first one that I always recommend to start with when you want to implement the DMAIC methodology within your plant is the 5S, which is to organize the workplace using the 5S. The 5S is a Japanese methodology that has 5 steps that will help you organize where you work in a way that it's easier to see the defects and it's easy to work. It's easy also to visualize what's going well, what's going wrong, and it's easy for anyone to see it, not only for experienced people, but also for operators or new employees, and also for customers. So, what is 5S about? The first step of 5S is to sort. It's to separate needed tools, materials, and instructions from those that are not needed. You have to remove everything that is not needed from the work area. So once you have split what you need from what you don't need, you need to store well what you actually need. You have to sort and organize all tools, equipment, files, data, materials, and resources for quick, easy location and use. You have to label all the locations on the tools and the equipment so that everyone can see it, can find it in less than 30 seconds. Yes, it's less than 30 seconds. If you are spending more than that to find any tool, then you're having a problem, and then you may be looking forward to implement 5S. So once you have stored all your precious material, your whatever it is, products, finished products, equipment, or any kind of material, then you need to set a new level of cleanliness in the shine step. You have to clean and remove all trash, grease, and dirt. What happens mostly in a manufacturing environment is that grease and dirt are a way of hiding defects. So as soon as possible that you can remove any grease, any dirt, any trash, then you will be able to see much better what's going wrong, what's going well. So if there's a machine that is not working, probably if it's clean, you will see exactly when you are getting a flow of water that shouldn't be there, or a flow of oil or grease that shouldn't be there. On top of that, cleanliness provides a safe work area and makes potential problems visible. So you will be able not only to see equipment links, as I said before, but also loose parts, missing rods, loose paperwork, materials, whatever. The first step for the 5S is to standardize, which we're going to see later on as well in the DMAIC, in the C control phase, okay? But it will also have it included in the 5S. So standardize would be to systematically do the 1, 2nd, and 3rd step of 5S. So you have to establish schedules for cleaning, you have to define the standards for each of the processes, and the 5th step is to sustain it. The only way that Lean Six Sigma can work is if you sustain it. You have to make Lean Six Sigma the same way as 5S as part of your culture. You have to build an organizational commitment so that this tool is sustained through time. Let me tell you one more thing. Toyota and Honda are very great fans of 5S. Toyota and Honda will tell you that 25 to 30% of all quality defects are directly related to order and cleanliness in the workplace. So that's really true. Now, what's more, this is also 5S is a great contributor to employee satisfaction at workplace because they feel more comfortable when they're working. So moving to the next tool. As you can see, this is some pictures of 5S where you can see some tools very well organized. You have these are all pictures of real examples of factories where employees have been working on 5S, trying to organize the parts, the materials for the work, the tools. So this helps them much better to improve the processes they do, improve how they work. They are much faster and they just know when they need something. The next picture will also show you how you can not only have signs on the tools, but also you can have signs on the floor just showing where you should include any kind of material so that you don't get them lost. This is another good example where you can have places to put all the materials that you need, but as much as possible that you can see them, that's much better. You may use labels, but you also can use transparent parts, you know, like drawers, transparent drawers, so that you can see everything that is inside, and you can figure out easily where you have to change it or where you have to buy more stuff. This is related to another tool that is very well used in Lean Six Sigma, which is the Visual Factory. Okay, this is the same picture for the drawer that we just saw. Remember this one? Okay. Let me go back. Do you remember this one? Okay. This one, on the door, you will see a sign which is red or green showing where you need to change either the tools or you need more material. So Visual Factory is a big part of Lean Six Sigma. You need visual signs to help you have real-time dashboards, real-time things that will tell you what to do and when to do it. And this helps a lot team leaders on the factory floor. You can see that Toyota is much more effective than General Motors in the sense that team leaders are 90% of the time on the factory floor because they have all the information they need right there. They don't have it on the computer. They just have it on the floor. And that's a very good thing about Visual Factory. Here you have another example. This is a box that is used to have glue for a factory, and you know the same employees just cut the box so that they can see inside how much glue they have, and it's easier for them to identify when they need to buy more. Another good tool for Lean Six Sigma to reduce waste is Pokayoke, which is mistake-proofing devices, which is the practice of striving for zero defects to prevent errors. It applies to any process where repetitive steps occur which could be skipped, performed out of order, or not conducted correctly. Mistake proofing ensures that tasks can only be done the right way. You can use lights, you can use signs, whatever you need so that you can show right away what's going right and what's going wrong. I also use very much the example of the Excel. When you are writing something that is not correct, when you are supposed to write a date and you're writing letters, then you will receive a message on the Excel file. The same in any ERP systems like SAP. You get a message showing, hey, this is not what you should be doing. So before you continue working on that, you already see what's going on. Another Lean tool that is very much used is SMED, which stands for Single Minute Exchange of Dies. And it refers to the time it should take to set up a machine to produce a part. It's very, very common. As you can see, there are some examples of companies that need to do fast changeovers. Well, SMED is a very good tool to reduce the time of the changeovers. In automatic plants, there are numerous instances where it would take like 3 or 4 hours to do a setup. So with the use of these Lean techniques, the setup time would be reduced to minutes. For example, the other day I went to Toyota plant, and really you were having like a new car every 110 seconds. Right? And it was any kind of car with any color. It wasn't like 10 black cars. No, it was a red car. 110 minutes later, you would have a black car. 110 minutes later, you would have like a van. No, it was wonderful. So that is basically one of the things that are great about SMED. Another tool is the total preventive maintenance, which is to try the operators to contribute to keeping the equipment in good condition. That's another great tool that you can use for Lean and Six Sigma. So how much time do you lose when you need to repair a machine? Well, you can create a flow if you just spend 1 or 7 minutes, every day before using it, and 2 minutes to clean it after, but you will never have the machine going down. Instead of just spending 3 hours every 2 weeks, just spend 5 minutes every day, and it will work much better, and you will know how it works. If your operators know how the machines work, they will be much better prepared to fix it faster and to make it work much better. Another tool is the Kanban. Kanban is a great tool, which is also very visual, and it's like a scheduling system, but it's rather a production control system, and it's not automated. It's a very, very simple tool. It's just cards, post-it notes, bin, pallets, whatever you need to visualize how things are labeled. You can use like these cards that I'm showing on the slide. You can use post-its to show how things are working. On the next slide, we're going to see that there are palettes that you can have in different colors, like in green, if something is already processed and ready to pack, or you can use red if something needs to be fixed or something needs to be arranged. Well, you can use, as I said, you can use cards telling you how much materials you need for any product. You can have cards to tell you if the product is approved. Well, there are you need a lot of imagination to be able to use well these Kanban cards, and you can use it in any process. It's very much like the waiter when they get your order at the restaurant. Well, that would be like a Kanban card if you got it to the chef on the kitchen. So all these tools were part of the improve phase. So now you have defined your process, you have measured how it should work, you have analyzed why it's not working that well, then you have improved it, and now it's time for control. You need to monitor what you have been working on to make sure it is sustained through time. So one of the tools that we use a lot for controlling is the control chart, which is an advanced form of Gantt chart which displays how stable is the process and what types of variation it is subject to. As you can see, this is a nice, well, it's not that nice, it's not very clean, right? But it's a very good place where you can get all the information you need on the line. Instead of just going to the computer, you just go to the plant, to the floor, and see what are the metrics for production, for cost, for quality, security, for HR. You can put whatever you need as long as you can measure it. And what I recommend is that the measures are done directly by the operator, that each of the employees can draw in a very simple graph how they are doing and which are the objectives, so that you can see if we are working well or not. In this case, for example, you have an objective of 1.3 when you are you are using paper, and you want to have it only to 1.3%. But in this case, they are having very, very bad numbers, as you can see, because they are on top of the objective. Okay? But this is something good because the operator exactly will know what is going wrong and which day it went wrong, and maybe they can figure out if there's something to correct on that particular day. So, as I said, control is part of monitoring and controlling, but you also need to try to have procedures. You need to standardize what you have been doing. The same thing that I mentioned with 5S, that the fourth step of 5S was standardizing. When you have your DMAIC methodology, in the control part, you also need to make sure it's sustained through time. And the only way to sustain a change through time is using standard operating procedures. That will be manuals, or that will be things that are standardized, ways of cleaning, ways of preparing a package, ways of solving a problem, ways of cleaning a certain tool or a certain machine, or ways to do a fast changeover. Well, you need to write it down. So in the case that you define with Lean or with SMED, you define a way to do your changeovers faster, then you need to write them down so that it helps everyone to find the best way to perform each operation. Okay, what happens is that if you have a small company, well, maybe there's just one person doing one of the activities, right? Maybe you have a restaurant and you have someone that is cooking, or you have a plant where you are having, as I said before, the example of the bottling company. Well, you need to find the best way to bottle every juice. So all must understand the notion that variation is equal to defects. So if you have reduced variation, you will reduce the defect levels. And the only way to reduce variation is to have standard work. That is, everyone doing things the same way, and the same way that is the best way. The best way that is discovered. Of course, everything what has to do with quality management, it also has to do with continuous improvement. So you need to focus on improving whatever you do, continue improving it every time. So maybe you once find the best way to perform one operation, but maybe the next day, one of the new employees realizes that there is a better way. Well, then you need to update your process and show them and communicate them so everyone else knows exactly what is the best way. So what is good about it is that work is to be performed according to the standard, but this rule applies to everyone, to hourly workers, to supervisors, to managers, to technicals, whoever. So everyone needs to have a standard for what they are doing every day. Okay?
The Six Sigma process is known as DMAIC. DMAIC comprises 5 phases: define, measure, analyze, improve, and control. These phases are the roadmap to problem solving and improving our processes. The effectiveness of Six Sigma method is derived from its structure. Each phase has an overarching objective and specific deliverables that need to be completed, which helps us achieve the objectives. The purpose of the define phase is to document the problem, the desired outcome, goals, and deliverables. The purpose of the measure phase is to obtain baseline process performance levels and quantify the problem. The focus of the analyze phase is to identify the key root causes for process variation and defects. The purpose of the improve phase is to develop, test, and implement the solutions. The goal of the control phase is to monitor the key factors and maintain the gains. You learn the aspects of the DMAIC process. Now we'll look at the tools used in each phase. The list of tools corresponds to the DMAIC phase in which they are used. The use or application of these tools gives the expected deliverables in each DMAIC phase for a green belt. Some of the tools listed are not required in every Six Sigma green belt project. These tools give us an insight into the problem and lead us toward the real issues in our processes. That is, with more experience, you're likely to know the tools you need for your projects. In the define phase, we use SIPOC, Voice of the Customer or VOC, Critical to Quality, CTQ, the Quality Function Deployment or QFD, Failure Modes and Effects Analysis, known as the FMEA or the FMEA, and the Cause and Effect C&E matrix. In the measure phase, we use Measurement System Analysis or MSA, control charts, process capability, and normality plots. In the Analyze phase, we use Simple Linear Regression, or SLR, Pareto charts, fishbone diagram, failure modes and effects analysis, the FMEA, multivariate charts, and hypothesis testing. In the Improve phase, we use brainstorming, piloting, and also the failure modes effects analysis and design of experiments, DOE. In the last phase, Control, we use control charts, a control plan, and measurement system analysis.
Pareto chart is a histogram ordered by the frequency of occurrence of events. It is also known as the 80-20 rule, or vital few, trivial many. It helps project teams to focus on the issues which cause the highest number of defects or complaints. To explain further, the given chart plots all the causes for defects in a product or service. The values are represented in descending order by bars, and the cumulative total is represented by the line. Pareto chart emphasizes that 80% of the effects come from 20% of the causes. Thus, a Pareto chart narrows the scope of the project or problem solving by identifying the major causes affecting quality. Pareto charts are useful only when required data is available. If data is not available, then other tools, such as brainstorming and multi-voting, should be used to find the root cause of any problem. Network diagrams are one of the tools used by the project manager for project planning. They are also sometimes referred to as arrow diagrams because they use arrows to connect activities and represent precedents and interdependencies between activities of a project. There are some assumptions that need to be made while forming the network diagram. The first assumption is that before a new activity begins, all pending activities have been completed. The second assumption is that all arrows indicate logical precedence. This means that the direction of the arrow represents the sequence that activities need to follow. The last assumption is that a network diagram must start from a single event and end with a single event. There cannot be multiple start and end points to the network diagram. Critical Path Method, also known as CPM, is an important tool used by project managers to monitor the progress of the project and to ensure that the project is on schedule. The critical path for a project is the longest sequence of tasks on the network diagram. The critical path in the given network diagram is highlighted in orange. Critical path is characterized by zero slack for all tasks on the sequence. This means that the smallest delay in any of the tasks on the critical path will cause a delay in the overall timeline of the project. This makes it very important for the project manager to closely monitor the tasks on the critical path and ensure that the tasks go smoothly. If needed, the project manager can divert resources from other tasks that are not on the critical path to tasks on the critical path to ensure that the project is not delayed. When a project manager removes resources from such tasks, he needs to ensure that the task does not become a critical path task because of the reduced number of resources. During the execution of the project, the critical path can easily shift because of multiple factors and hence needs to be constantly monitored by the project manager. A complex project can also have multiple critical paths.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.